So you have to remember the formula as x by 2 into under the root of x squared minus a squared by 2 into log of modulus of x plus under the root of x squared minus a squared plus c. X replaces x plus 2, a replaces root 2. The formula will goes like this: under the root x squared minus a squared into dx is x by 2 into under the root x squared minus a squared by 2 into log of modulus of x plus under the root x squared minus a squared. Hello dear students, a warm welcome to one and all. My name is Vibha, Mathematics faculty at Vidhyaashram, Pre-University College, the Temple of Excellence, Mysuru. In the last session, we have learnt many problems on integration by partial fraction. In today's session, dear students, here we are having session number 16 and here chapter number 7 called integrals. And what are all the topics we are going to study under this session is nothing but integrals of some more types. Therefore, for this, you have to know the formula derivation and also you have to remember that, and then based on those, you need to solve the problems. Now, without any delay, let us move on to the formula proof, dears. Now, what they have asked? First, a formula is integral of root of x squared minus a squared into dx. Now, let us find this integral. What happens? You need to prove this is equal to, see here, let me take it as integral of root of x squared minus a squared into dx. Integral of x squared minus a squared into dx should be reduced to the form of x by 2 into under the root of x squared minus a squared divided by 2 into log of modulus of x plus under the root of x square minus a square plus c. And this what you need to prove, dears. Now let us take the left hand side, whatever they have given. It is nothing but integral of under the root x square minus a square into dx. Now here I am going to take as a first function is nothing but the constant. What is a constant? Constant is nothing but anything into 1 it will be the same thing, isn't it? Therefore, let me write the given function as under the root x square minus a square into 1 into dx. Now, why I am taking like this? I am going to do this by integration by parts. Now, what is integration by parts? Integral of f of x into g of x. First function into integral of second function minus integral of differentiation of first function into integral of second function, isn't it? According to iLearn rule, when you move on to the integral by parts, you need to remember the rule that iLearn. That means inverse trigonometry, logarithmic, algebraic, and then trigonometric and then exponential, isn't it? So here accordingly, what is first you are going to take it as? Let me take it as 1 is nothing but it is a constant, right? So I am going to take the constant function will come at last. So first it will be algebraic. Algebraic is nothing but under the root of x squared minus a squared. So let me choose this one as a first function and then let me choose 1 as a second function. Understood? Now let me write down the formula here. Integral of f of x first function into g of x into dx is nothing but first function into integral of second function, that is a g of x, minus integral of d by dx of, that is a differentiation of first function, into integral of second function into dx, right? According to this formula, let me take the first function as root of x squared minus a squared, second function as is nothing but 1. So accordingly, if we do, we are going to get it as first function, see, first function into integral of second function minus integral of d by dx of first function into integral of second function, isn't it? Into dx, right? So here, let me take the given integral is nothing but I. Which one? This one. So let this will be is equal to I. So left hand side is always is going to be what? I only. Are you getting? So I, which implies I is equal to, I am taking it as, right? Now here, let me integrate this, which implies under root x squared minus a squared, integral of 1 into dx is nothing but x minus integral of, what is d by dx of under the root x squared minus a squared? Under the root x, d by dx is nothing but 1 by 2 root x, isn't it? So therefore, 1 divided by 2 root x square minus a squared, again chain rule, differentiating the inner side is nothing but differentiation of x squared is 2x into 2x, isn't it? So, and again integral of 1 into dx is nothing but x into dx. This dx I am writing. I hope you got this one. Now 2 will get cancelled. What will be the next step? So I will be is equal to under the root of x square minus a square into x minus integral of, see, 2 will get cancelled, remaining is x into x is nothing but x square. So x squared into 1 is x square only, x square divided by under the root of x square minus a squared into dx. I hope you understood this step. Now here, what is the denominator? Denominator, you are having a combination of x squared and then a squared, isn't it? Otherwise x and a. So numerator also, let me make it as in the form of x and a. Numerator, you are having only the x term, so I want a term there. So I am going to subtract and add a square, isn't it? So therefore, which is equal to under the root x squared minus a squared into x minus integral of x squared. I am going to subtract a squared and then add a square. Under the root x square minus a square into dx. From here, I am going to segregate. What is the segregation? Which implies root x square minus a squared into x minus x square minus a square divided by root x square minus a squared. Here minus into plus is nothing but minus. A squared is a constant I can bring outside. 1 divided by root x square minus a squared into dx. I hope you understood this one. Now here, this can be written as, what is root x into root x? Root x squared minus a squared into root x square minus a squared is nothing but x squared minus a squared, isn't it? Now writing that x squared minus a squared as like this, okay? So therefore, you can have under the root x square minus a square into x minus, see, if you write like this, one root and this root will get cancelled. Remaining is in the numerator under the root of x square minus a squared into dx. So into dx you have to write, dear students, minus a squared, because I have segregated, 1 divided by under the root of x square minus a squared into dx. Now here left hand side you are having already what is? It is nothing but I. Now here what this will become? I only. Now minus I taking to that side, it will become plus I. So I plus I, what happens? So you can have I plus I will be is equal to root x square minus a squared into x. So minus a squared into, this will become log of modulus of x plus under the root of x squared minus a squared plus c. So we have already proved that proof, right? That formula. I plus I will become 2i. 2 will be shifting to that side. So I will be remaining x divided by 2 under the root of x squared minus a squared minus a squared divided by 2 into log of modulus of x plus under the root of x squared minus a squared plus c. And this is your final proof. You are going to get it as, dear students. This formula you have to remember to solve the problems. So you have to remember the formula as x by 2 into under the root of x squared minus a squared by 2 into log of modulus of x plus under the root of x squared minus a squared plus c. So I hope you got this one. We'll be moving on to the next proof, which they have asked under the root of x squared plus a squared. So what do you need to prove here? You need to prove that which happens x by 2 into root x square plus a square divided by 2 into log of modulus of x plus root x square plus a square plus c. This you need to prove, dear students. Now let me do accordingly. Now let me take this one as a first function. What is that? Under the root x square plus a square into 1 into dx. Now choosing this one as a first function, choosing this one as a second function. Now which happens according to the formula, first function into integral of second function minus integral of d by dx of first function into integral of second function into dx. Now this will come, see here, under the root x square plus a squared into integral of 1 into dx is x minus d by dx of x squared plus a squared under the root is what? Root x differentiation is nothing but what? 1 divided by 2 root x. So first consider this one as root x, which will become 1 divided by 2 root x. Again inner side differentiation. X squared plus a squared. X squared differentiation is 2x into 2x. A squared differentiation is 0. 2x plus 0 is 2x only, right? So into integral of 1 into dx is x into this dx I am writing. I hope you got this one. Now 2 will get cancelled. Remaining is under the root x square plus a square into x minus here x into x will be x square divided by root x square plus a squared into dx. Now same as like the before, you do not have numerator in the combination of x and a, so I am adding and subtracting a square to the numerator. So what happens to that condition? Which happens, I will be is equal to, because I have called that one as I here, let I is equal to, okay, I is equal to, I hope you got this one. Now which implies x into under root x square plus a square minus integral of, see here, x square plus a square minus a square divided by root x square plus a squared into dx. Now I am segregating this, dear students. I will be is equal to x into under the root x square plus a square. See, minus as it is x square plus a square divided by root x square plus a square into dx. See, minus into minus is plus. A squared is a constant, I can remove outside. Let me remove later. X square plus a square into dx, right? Now this will become what? Which implies that is I is equal to x into under the root x square plus a squared here minus integral of x squared plus a squared can be written as root x squared plus a squared into root x squared plus a squared. One term will get cancelled. Remaining is what? Under the root x square plus a squared into dx. Now plus a squared into 1 divided by under the root x square plus a squared into dx. Now dear students, what is this? This will be I, taking to that side, which will become 2i. Now 2 can be shifted to down, so which will be I is equal to, I am writing directly, I will be is equal to x by 2 into under the root x square plus a square here plus a square divided by 2 into, this will become log of modulus of x plus root x square plus a square plus c, and this is your proof. You are going to get it as dear students. I hope you understood this proof, and remember this proof also and the formula. So you are going to solve the problems based on this, and this type of formula proof will be asked for a 5 marker in your final examination along with the simple problem. Now we'll be moving on to the next formula proof. What they have asked, integral of a squared minus x squared into dx. So what you need to prove here? So you have to prove that, which implies x by 2 into under the root a square minus x square plus a square divided by 2 into sine inverse of x by a plus c. This is what the proof you need to prove it here, right? So next you have to prove, dear students, let me prove under the root of a square minus x squared into dx is equal to x divided by 2 into under root a square minus x squared plus a square by 2 into sine inverse of x by a plus c. Okay, let us prove this one. So what happens here? You are going to get it as same like we are having under the root a squared minus x squared into dx. I am going to call this one as let it be is equal to I. So let this implies that under the root of a square minus x squared into 1 into dx. Okay, let me take this as a first function and this is a second function. This is the first one and this is the second one. So therefore you are having I will be is equal to first function into integral of second function again minus integral of d by dx of first function into integral of second function into dx. Now this happens under the root a squared minus x squared. Integral of 1 into dx is x minus this will become what? D by dx of this is 1 divided by 2 root a squared minus x squared into a squared differentiation is 0 minus x squared differentiation is minus 2x, right? Minus 2x into 1. Again, you are having integral of 1 into dx is x into dx. Now again this will become what? So I will be is equal to under the root of a square minus x squared into x. Now again segregate and see minus into minus is plus. 2 will get cancelled, right? So plus x into x is x squared. I am going to subtract what is that a squared and add it a squared. Now divided by under the root a squared minus x squared, right, into dx. Now I hope you are getting this one. Now here we'll be moving on to next step. Under the root a square minus x squared into x. This will become x squared minus a squared. By taking a minus sign common factor, you are going to get it as minus a square minus x squared under the root a squared minus x squared. Again here plus into plus is plus only. So plus a squared into 1 divided by under the root of a squared minus x squared into dx. Now what this will become, dear students? You are going to get it as I will be is equal to under the root a squared minus x squared into x minus under the root a squared minus x squared. I hope you are getting this one. Plus a squared into 1 divided by under the root of a squared minus x squared into dx here into dx here. Now what happens? You can take this one as it's nothing but I. So I plus I will become 2i. So I will be is equal to x divided by 2 into under the root a squared minus x squared plus a squared divided by 2 into what this will be? Sine inverse of x by a plus c. I hope you got this proof also. Now based on these we'll be solving the problem, dear students. Okay. Now let me move on to the problem. Integrate under the root 4 minus x squared. Now how I can write this one as? Which happens under the root 4 I can write it as 2 squared minus x squared into dx. Just now we have solved the problem. Now we know that under the root of a square minus x square integral of dx will be is equal to x by 2 into root a squared minus x squared plus a squared by 2 into sine inverse of x by a plus c, right? So therefore here a is nothing but 2 and x is same you are going to get. So which happens, see, under the root of 4 minus x square integral dx will be is equal to x by 2 as it is under the root 2 squared minus x squared plus a squared by 2 is 2 squared divided by 2 into sine inverse of x by a is x by 2 plus c. Now 2 will get cancelled. You can have x by 2 into under the root 2 squared is 4 minus x squared plus 2 into sine inverse of x by 2 plus c. And this is a simpler problem they are going to give you along with the problem. That is along with the formula proof. Okay. Now we'll be moving on to the next one. Integrate 1 minus 4x squared. So you can write this one as integral of 1 squared minus 2x whole squared, isn't it? So in place of x you are having 2x, which is of the same formula just now we have written. So which implies that you can have x by 2, which is 2x divided by 2. In place of x, 2x you are having under the root 1 squared minus 2x whole squared, isn't it? Plus a squared by 2. In place of a you are having 1. So 1 squared divided by 2 into sine inverse of x by, in place of x you are having 2x divided in place of a is 1 plus c. I hope you got this one, which happens 2 will get cancelled. X into under the root of 1 squared is 1. 2x whole squared is 4x square, isn't it? So plus 1 squared is 1 by 2 into sine inverse of 2x divided by 1 is something but 2x plus c. And this is your final answer. Now we'll be moving on to the next problem. Integrate under the root x squared plus 4x plus 6. Now this is not in the form of either x squared plus a squared, x squared minus a squared minus x squared. So you need to solve this according to by completing square method. Now here let me take whatever the inner side, x squared plus 4x plus 6, right? Now you have to make this one. First check coefficient of x squared. Coefficient of x squared must be equal to 1, and then later on move on to coefficient of x, and then you have to divide half of that, okay, and then you have to whole square of that. Understood? Here coefficient of x squared is 1, so no need to worry about. Now move on to coefficient of x, which is 4. Half of 4 is 2. Whole square of that one, which is 4, adding and subtracting. So therefore x squared plus 4x, so plus 2 squared plus 6 minus 2 squared. I hope you understood this one. Now this will become what? A squared plus b squared plus 2ab, isn't it? So therefore here you can have x plus 2 whole squared. If you expand x plus 2 whole squared, what happens? X squared plus 4 plus 2 into 2x, which is 4x. Same you are going to get it. Now 6 minus 2 squared. What is that? 6 minus 4. So therefore x plus 2 whole squared plus 6 minus 4 is nothing but 2. Now otherwise x plus 2 whole squared you can write plus root 2 whole squared. Why? I want to write it in the form of x squared plus a squared. So therefore I can write this one as, which implies integral of under the root of x plus 2 whole squared plus root 2 whole squared into dx. And this is of the form under the root x squared plus a squared integral dx, which implies that x by 2 into under the root x squared plus a squared. So plus you are having a squared divided by 2 into log of modulus of x plus under the root x squared plus a squared plus c. Right? Accordingly, x replaces x plus 2, a replaces root 2. Okay? So therefore, which implies x plus 2 divided by 2 under the root x plus 2 whole squared plus root 2 whole squared plus a replaces root 2 whole squared divided by 2 log of modulus of x plus under the root of x plus 2 whole squared plus root 2 whole squared plus c. Okay. Now further simplification, it will be giving you x plus 2 divided by 2. Now expanding this, it will get back to the same form, which is x squared plus 4x plus 6. Again plus root 2 whole squared is 2. So this will get cancelled. You are remaining with log of modulus of x plus 2, here x plus 2, because in place of x, x plus 2, understood? So x plus 2 plus under the root of what is this? X squared plus 4x plus 6 plus c, okay? And this is your final answer. You are going to get it as, please make a correction that in place of x, it should be x plus 2. That's it. And this is your final answer. You are going to get it as. I hope you understood this one. Now we'll be moving on to the next, integral x squared plus 4x plus 1 into dx. Now you're having, this is also not in the form of any, what we have proved now the formulae. Let us bring it to the form. First take it the, whatever the inner side the bracket. First take it whatever the inside the square bracket. X squared plus 4x plus 1. Check coefficient of x squared must be 1. Yes. Now see the coefficient of x, which is 4. Half of that, which is 2. Squaring that, which is 4. Adding and subtracting. Now here x squared plus 4x plus 2 squared plus 1 minus 2 squared. Now you can have, this will be is equal to x plus 2 whole square. Now again plus 1 minus 2 squared is nothing but 4. Therefore x plus 2 whole square. 1 minus 4 is nothing but minus 3. Otherwise, x plus 2 whole square minus root 3 whole square. Right. Therefore, I can have this one will be implies that under the root, this can be reduced x plus 2 whole square minus root 3 whole square into dx. which is of the form what? Under the root x square minus a squared into dx is equal to x by 2 into under the root x square minus a squared plus a square divided by 2 into log of modulus of x plus under the root x square minus a square under the root x square minus a squared plus c. Dear students, the formula will goes like this. Under the root x squared minus a squared into dx is x by 2 into under the root x squared minus a squared by 2 into log of modulus of x plus under the root x squared minus a squared. So here x replaces x plus 2, a replaces root 3. So replacing that, x replaces x plus 2. So x plus 2 divided by 2 under the root of x plus 2 whole square minus root 3 whole square minus a squared by 2 is root 3 whole square divided by 2 into log of modulus of x replaces x plus 2 plus under the root of x plus 2 whole square minus root 3 whole square plus c, right? Now, if you reduce this, it will go back to the same step, which is x squared plus 4x plus 1. So, let me write that, which implies x plus 2 divided by 2 into under the root x squared plus 4x plus 1 minus root 3c, root will get cancelled, minus 3 by 2 into log of modulus of c x plus 2 plus under the root x squared plus 4x plus 1 plus c. I hope you understood this one. Now we'll be moving on to the next problem. What they've asked, integrate 1 minus 4x minus x squared. Now you have to make the inner side as coefficient of x squared must be equal to 1 and then check for coefficient of x. Now let me write whatever the given, 1 minus 4x minus x squared. Now taking minus sign common, you are getting x squared plus 4x minus 1, isn't it? Now let me do coefficient of x squared, we made it as 1. Now see the coefficient of x, which is 4, half of that is 2, whole squared of that, adding and subtracting. Now here x square plus 4x plus 2 squared, again minus 2 squared minus 1. Now which will become, this will be x plus 2 whole square. Now again minus 2 squared is minus 4 minus 1. So minus x plus 2 whole square. Now minus 4 minus 1 is minus 5. Now multiplying the minus sign, first will come 5, which can be written as root 5 whole square. Again this will come negative, minus of x plus 2 whole square. I hope you understood this one. Multiplying the negative into positive is negative, negative into negative is positive. This 5 I have written root 5, that's it, whole squared, which is root will get cancelled, going back to the same step, because why I have to write it in the form of a squared minus x squared. Now you know a squared minus x squared is what? So therefore under the root of root 5 whole squared minus x plus 2 whole squared, which is nothing but x by 2, x replaces x plus 2, x by 2 divided by 2, x plus 2 divided by 2 under the root 5 whole square minus x plus 2 whole square, right? So plus a square by 2, a is nothing but root 5 whole square divided by 2 a squared, right? Into sine inverse of x by a, x replaces x plus 2, a replaces root 5 plus c. And final step will be equal to x plus 2 divided by 2. Simplify this, you are going back to the same step, which is 1 minus 4x minus x square into, here you are getting plus root will get cancelled, 5 by 2 into sine inverse of x plus 2 divided by root 5 plus c. And this is your final answer. You are going to get it as DS. Now we'll be moving on to the next one, under the root x squared plus 4x minus 5. Now this is also, take the inner side, x squared plus 4x minus 5. Now see the coefficient of x squared, yes it is 1. Move on to the coefficient of x, which is 4, half of that and whole squared of that. So therefore x square plus 4x, half of 4 is 2, 2 squared minus 2 squared. So minus 5 minus 2 squared. Now this will become what? X plus 2 whole squared, right? A squared plus b squared plus 2ab. So minus 5 minus 4. So which will be x plus 2 whole squared. Minus 5 minus 4 is nothing but minus 9. Otherwise x plus 2 whole squared minus 9, which is minus 3 squared, right? which is in the form of x squared minus a squared. So therefore, which implies integral of this can be reduced to the form of x plus 2 whole squared minus 3 squared into dx, which implies x by 2 into x replaces x by 2 and a replaces 3. So into under the root x plus 2 whole squared minus 3 squared plus a squared by 2, that is 3 squared divided by 2 into log of modulus of x plus minus a square divided by 2 log of modulus of x replaces x plus 2 plus under the root of x plus 2 whole square minus 3 square. Now simplifying further, this will reduce to the form of x squared plus 4x minus 5, writing that, which implies x plus 2 divided by 2. Now under the root of x squared plus 4x minus 5 plus 3 squared by 2, which is 9 by 2, right? Which is minus 9 by 2 into log of modulus of x plus 2 plus this will become under the root x squared plus 4x minus 5 plus c, right? So, and this is your answer. You are going to get it as DS students. I hope you understood this one, how to have the solution according to the formula. Okay. Now, we'll be moving on to the next problem. What they've asked, under the root x squared plus 3x. Now, this is also not in the form of any one of those formulae. Now, taking that x square plus 3x. Now, what is x squared coefficient? Yes, it is 1. Moving on to the x coefficient, 3, half of that, 3 by 2, right? So, adding whole square of that, 3 squared by 2 squared, adding and subtracting, x squared plus 3x plus 3 by 2 whole squared minus 3 by 2 whole squared, adding and subtracting that. So, this will become what? X plus 3 by 2 whole squared minus, which implies minus 3 by 2 whole square. Now, this is of the form x squared minus a squared. I can write that one, which implies integral of under the root of, what is that? X plus 3 by 2 whole squared minus 3 by 2 whole squared, right? Into dx, which will be here x squared minus a squared. Just now we have wrote down the formula. X replaces here x plus 3 by 2. Remember, a replaces here 3 by 2. Okay. So, x plus 3 by 2 whole over 2 into under the root of x plus 3 by 2 whole squared minus 3 by 2 whole squared. Again, reducing this, going back to the same step. Now, minus a squared by 2 means 3 by 2 whole squared whole over 2 into log of modulus of x replaces x plus 3 by 2 plus under the root of x plus 3 by 2 whole squared minus 3 by 2 whole squared plus c. Further simplification gives you what? Now here, taking LCM as 2, 2x plus 3, 2 will get cancelled. Remaining is only 2x plus 3 into under the root of, this will go back to the same step, which is x squared plus 3x minus, again here 2 squared will come to the denominator. 2 squared is nothing but 4. 4 into 2 is 8. So, 3 divided by 8 into log of modulus of, taking LCM, 2x plus 3 divided by 2 plus under the root, this will become x squared plus 3x, right? Plus c. And this is your final answer. You are going to get it as DS. I hope you understood this one. Now, we'll be moving on to the next problem, DS. What they've asked. Now, dear students, this is not in the form of a squared plus x squared. You can write x by 3 whole squared, or let me take the LCM. If I take the LCM, what happens? Under the root, 1 plus x squared by 9 into dx is nothing but integral of 9 is the LCM, 9 plus x squared divided by 9 under the root into dx. Now here 1 by root 9 is nothing but 3. So therefore you can have integral root of 9 plus x squared into dx divided by root 9. Root 9 is nothing but 3. So 1 by 3 can be written outside. So this will become 9 can be written as 3 squared plus x squared into dx. Now this is of the form x squared plus a squared or a squared plus x squared. So we know that, so 1 by 3 is already outside, 1 by 3 into, open the bracket, x by 2, x replaces here x only, x by 2 under the root of 3 squared plus x squared plus a squared by 2, a squared is 3 squared by 2 into log of modulus of x plus under the root of 3 squared plus x squared plus c, right? Now here you can close the bracket, 1 by 3 into, so therefore you can have, see, 1 by 3 into x by 2 is x divided by 6 under the root of 3 squared plus x squared plus 3 squared by 2 is 9 by 2 into log of modulus of x plus under the root 3 squared plus x squared plus c. And this is your final answer. You are going to get it as, dear students. So x by 2 into 3, which can be written as 6, right? Because 3 into 2, which is x by 6, you can write it as. And that is your final answer. I hope you got the session how to solve the problems based on integrals of some more types. In the next session, we'll be moving on to, dear students, the new concept, which is a definite integral of this chapter, integrals itself. So keep watching, dear students. Have a nice day.